Okay, in this question we're going to employ the fundamental theorem of calculus to evaluate this definite integral. And so we're required to evaluate the integral from 0 to pi on 6 of sec x plus tan x squared dx. Right, now there's a number of ways we can do this. The first thing that we should do is we should expand out this square. Okay, so our function sec x plus tan x all squared can be written as, so let's do this, pi on 6, 0 to pi on 6, we want the integral of it, of sec squared x plus 2 sec x tan x plus tan squared x, and we're doing that with respect to x. Okay. Alright, so now there's a couple of things we can do. We know how to find the integral of sec x. It's the antiderivative of sec squared, and of course when we're differentiating tan x we would get sec squared, so we know how to get that. Sec tan, we also know how to do that because that would indeed be the the derivative of sec x is sec x tan x, so going backwards that would give us a sec x. The problem one we have is this tan squared x. However, we do know that 1 plus tan squared x is equal to sec squared x. Okay, so this is one of our trigonometric identities, and so what we can do here, of course, is replace this as being tan squared x could be equal to sec squared x minus 1. Right, now using that, our integral becomes the integral from 0 to pi on 6. Okay, come across here a little bit, and we're going to have this as sec squared x plus 2 sec x tan x, and then we're going to have 1 plus, or rather sec squared x subtract 1, and that's with respect to x. So we put our dx there. Right, now we can simplify that down, and so we can get this as the integral from 0 to pi on 6 of 2 sec squared x plus 2 sec x tan x subtract 1. Okay, now we can split this integral up just to make it easy. We can pull out the 2 as a multiple. We can do that with an integral, and this will be over sec squared x dx plus a 2 integral from 0 to pi on 6 of sec x tan x dx. Don't forget your dx's. And then we're going to have subtract the integral from 0 to pi on 6 of 1 dx. Alright, so that's where we are so far. Now we can do each integral separately. So this will be 2, and the integral of sec squared dx, of course, will be tan x, and we're going to use the fundamental theorem of calculus to evaluate that. So it's from 0 to pi on 6 plus 2, and of course the integral of sec x tan x will in fact be sec x from 0 to pi on 6 as well. And finally we would have this as subtract x, because the integral of 1 would be x from 0 to pi on 6. Right, now it's left to us to evaluate these. So we're going to have 2 by the tan of pi on 6 minus the tan of 0 plus 2 by the secant of pi on 6. This is the fundamental theorem of calculus. Subtract secant of 0, and minus now pi on 6 subtract 0. Okay, so there's our integrals done, and we're looking to evaluate these. Right, so of course now we want to do is find what is going to be the tangent of pi on 6. Right, well pi on 6 is 30 degrees. So we need the tan of 30 degrees. So really it's the sine of 30 over the cos of 30, and of course the sine of 30 is going to be a half. So it's a half over root 3 on 2, so it's going to be 1 on root 3. Okay, and of course the tan of 0 is 0, plus 2. Now the secant of pi on 6, so this is 1 over the cos of pi on 6. The cos of pi on 6 is root 3 on 2, so this will be 2 on root 3. Subtract, and of course 1 on cos is secant, so 1 over the cos of 0, the cos of 0 will be 1, so we'll be subtracting 1. And we're going to subtract off pi on 6. Okay, so we're going to end up here now with 2 on root 3. Okay, so this will now be 2 on root 3 plus 4 on root 3. Subtract 2, subtract pi on 6. So this will now become 6 on root 3 minus 2 minus pi on 6. And of course it now just comes down to simplifying this. Now if I multiply top and bottom by root 3, I get 2 root 3. Okay, because I have a root 3 here. That'll give me a 3 on the bottom and 6 root 3 on the top, so 3 and 6 go 2. Subtract 2 minus pi on 6, and this would be the value of my integral, alright, of sec x plus tan x squared from 0 to pi on 6.